Hi guys, this video I'm going to show you guys how to find the quadratic rule from a graph. Now I did have a previous video on this, so if you want to check that out, go check that out. But this is another example where the graph is slightly different to the one we've seen. So the first video showed you a graph where there was very clear x-intercepts or roots, but in this graph you can see that I've actually given one turning point, or in fact it's actually one x-intercept. Okay, so let's have a look at this graph. Now this graph is really special because there's only one root, and most of the time we're dealing with quadratics where they have two roots. So this one's very special because it just touches, it just touches, if it's going to let me, there we go, it just touches the x axis. So in this question, what we're going to do is we're going to use this point as a turning point, because essentially that's what it is. It's turning, and on the x-axis turning upwards, so that x-intercept's actually now also a turning point. So we're going to use that to help us find out our rule. Okay, now this time I'm going to use a different rule. Now this is called, that's meant to be a Q. In this particular circumstance, I've got a question where I want to put in turning point form because that's the easiest for me. To do it in root form, because remember there's another one that's root form. This is the one that we did before. Now, these are when you have two x-intercepts. That's not going to be useful for me because in this particular circumstance, I've only got one. How am I going to substitute that one thing into there? It's not going to work. So, I can't do that. So I'm not going to use this format. I'm going to use a different one. I'm going to go now and substitute my turning point into this turning point form right here, where P is the x coordinate and Q is the y coordinate. So for this point here, this is the same as 2, 0. I might as well label my y-intercept as well. This is 0, 8. So I'm going to now put this turning point, because that's where it turns, that's where the graph changes direction. I'm going to put that value, or put that coordinate, into my P and Q. So y is equal to a, because we need to figure out that scale factor later. So we'll get back to that. X, now remember that's a takeaway. It says take 2. Squared plus 0, because the y coordinate for my Q, or for my turning point, is 0 there. Okay, so I'm now going to just kind of clean this up and substitute a coordinate in to find out my a. So this is the same as x take 2 squared. Now I'm going to substitute my y-intercept in. I'm going to substitute another coordinate, so that one there. So let's do that. So I'm going to write that down. I'm subbing in 0, 8. I'm going to write down 8 is equal to a 0 take 2 squared plus 0, which is nothing. So 8 is equal to negative 2 squared is 4, positive 4. I'm going to divide by 4 on both sides to cancel that out to get a on its own. So a is equal to 2. So that means the rule I've got is 2 x take 2 squared. So 2 is my dilation factor, which you can't work out from the graph, which is very important for why you need to actually substitute this coordinate in, or any coordinate that you're given, into the equation to actually find out that a, because we can't always ever assume that it's 1. So in this case, you can't really tell. You can't just look at a graph and kind of figure that out. So it's important that you actually work that out using a coordinate. And we substituted our turning point in as well. Okay.